Welcome to my 49th tutoring session in A-level chemistry. In this video, I'll give a detailed explanation about the mole concept and the significance of Avogadro's number. Kindly subscribe my channel, share, like, comment, and watch the full video. Now, to measure different quantities, we use different parameters. Like for example, we measure the length in centimeters or meters. We measure the mass in grams or kilograms. We measure the time in seconds, minutes, or hours. And we measure the temperature in degree centigrade, degree Celsius, or in Kelvin scale. But what about the chemical substance? That is where the mole concept comes into picture. Now, mole is a fundamental concept in chemistry. It is a chemist's measure of a chemical substance. The mole measures the number of atoms, molecules, or ions in a given chemical substance. Now, the molecular formula for the chemical substance glucose is C6H12O6. 1 mole of glucose is equivalent to 180.156 grams of a chemical substance. That's it, say 1 mole contains 6.022 into 10 to the power of 23 molecules of glucose. So if you weigh out 180.156 grams of glucose, it means that the weighed amount of glucose contains 6.022 into 10 power 23 molecules of glucose. So mole is a chemist's measure of a chemical substance. So to measure different quantities, we use different parameters. That is length in centimeters, mass in kilograms, and temperature in Kelvin. Likewise, the mole measures the number of atoms, molecules, or ions in a given chemical substance. A mole concept is a fundamental concept in chemistry that allows us to measure and relate the amount of substance on a macroscopic scale. Now, mole concept is based on Avogadro's number, which represents the number of particles. And these particles could be either atoms, molecules, or ions in 1 mole of a given chemical substance. Now, Avogadro's number is approximately 6.022 into 10 power 23 number of particles. And these particles could be either atoms, molecules, or ions. Now, the unit mole is used to express the amount of chemical substance, similar to how a dozen is used to express a specific quantity, that is 12 items. So when we say dozen, it means it represents 12 items or 12 numbers. So likewise, Avogadro's number is equivalent to 6.022 in 10 to the power of 23 number of particles. So remember, 1 mole is equivalent to the Avogadro's number, that is 6.022 into 10 to the power of 23 particles. So 1 dozen represents 12 items or 12 numbers, while 1 mole represents the Avogadro's number, that is 6.022 into 10 to the power raised 23 particles. And these particles could be atoms, molecules, ions, or even electrons. Now let's apply the mole concept or consider the mole concept in terms of atoms. Like for example, in case of hydrogen atom, 1 mole of hydrogen atom contains 6.022 into 10 to the power of 23 atoms. That is 1 gram. So where did this number 1 come from? That is 1 gram come from? It is the atomic weight of hydrogen. So hydrogen contains 1 protons in its nucleus, and thereby you have to consider it as 1 atomic unit. 1 mole of hydrogen is equal to 1 gram and contains Avogadro number of atoms. Similarly, 1 mole of carbon contains Avogadro number of atoms, that is 12 grams. So where do we get this number 12? Is the atomic weight, that is the total number of protons and neutrons present in the nucleus of the carbon atom. So carbon atom contains 6 protons and 6 neutrons in the nucleus. So when we sum it up, we end up with 12. So atomic weight of hydrogen is 1, containing Avogadro number of atoms. Atomic weight of carbon is 12, containing Avogadro number of atoms. Now let's consider the the mole concept in terms of molecules. Like for example, methane molecules, water molecules, and oxygen molecule. So in case of water, 1 mole of water contains Avogadro number of molecules, that is 18 grams. And where did we get this number 18? So 18 is the molecular weight of water. So here, since we are talking about the mole concept in terms of molecules, we have to consider the molecular weight. So in case of hydrogen and carbon, we are considering the mole concept in terms of atoms. So there we have to consider the atomic weight. So here, since we are considering the mole concept in terms of molecules, we have to consider the molecular weight. So 1 mole of water contains Avogadro number of molecules, that is 18 grams. So molecular formula of methane, water is H2O. So water molecule, it contains 2 hydrogen atoms and 1 oxygen atom. So in case of water molecule, the oxygen atom is covalently bonded to 2 hydrogen atoms. So atomic weight of hydrogen is 1. Atomic weight of oxygen is 16. 16 plus 2 equals to 18. So 1 mole of water, it contains Avogadro number of molecules, and 1 mole is equal to 18 grams. Now the mole concept can also be considered in terms of ions and electrons. That is number of ions as well as the number of electrons. So the Avogadro number of particles could be either in terms of atoms, molecules, or ions, or even electrons. Now the term mole is similar to the dozen term. Just as a dozen represents 12, the mole represents the Avogadro number. And this Avogadro number is a very large amount. This is because the atoms and molecules are very minute. They are very small. So the mole is also referred to as Avogadro number of particles. An atom is the smallest unit of an element. It has a central nucleus that contains positively charged protons and electrically neutral neutrons, with the negatively charged electrons orbiting around the nucleus in their respective shells or energy levels. So when you are trying to consider the weight of an atom, we have to consider the weight of a proton, neutrons, as well as electrons, as these are the subatomic particles which constitutes a atom. So atomic weight will be the sum of these subatomic particles, that is protons, neutrons, and electrons. And each subatomic particle will be considered as 1 unit. So proton will be considered as 1 unit, neutron will be considered as 1 unit, electron will be considered as 1 unit. So mass of 1 proton is 1.673 into 10 to the power minus 27 kilograms. So we are considering proton as a unit, atomic unit. So when you consider the mass of this particular proton unit, it will be considered as 1 atomic mass unit. So proton is a 1 atomic mass unit. The mass of one neutron will also be 1 atomic mass unit, is equivalent to 1.675 into 10 to the power minus 27 kilograms. Now, when you compare and contrast the mass of proton to that of neutron, we find that the mass of neutron is slightly heavier than that of proton. And what about electron? Mass of one electron, it is also a unit. So, one atomic mass unit of electron will be 9.109 into 10 power minus 31 kilograms. So, the ratio of masses 1 is to 1 is to 1850, which means that the mass of electron is nearly 2000 times lighter than that of the mass of proton and neutron. So, atomic weight will be the sum of protons, neutrons and electrons. But as we see from the values, the electrons have a negligible mass, so we kind of ignore it in the atomic weight calculation. So why we ignore the mass of electron in the atomic weight calculation? Because its mass is nearly 2000 times lighter than that of proton and neutron. So we kind of ignore it in the atomic weight calculation. So atomic weight will be sum of protons and neutrons, ignoring the mass of electron. Now in case of hydrogen atom, the hydrogen atom, it contains one proton in its nucleus, and therefore its atomic weight will be 1, because there are no neutrons in the nucleus. So we consider in terms of atomic mass unit. So proton is 1 unit. But if you consider the mass in terms of the atomic mass unit, so it is not a weighable quantity. So you cannot weigh hydrogen atom using a weighing balance, because it's so minute with a negligible mass. So but the mass can be weighed in grams. That is, the quantity is weighable in grams. So 1 gram of hydrogen can be weighed using balance. So 1 mole of hydrogen is equivalent to 1 gram. That is to say, 1 gram of hydrogen contains Avogadro number of atoms. What about carbon atom? The nucleus of carbon atom contains 6 protons and 6 neutrons. So atomic weight is sum of protons and neutrons. That is 6 plus 6, that is 12. So 1 mole of carbon is 12 grams, containing Avogadro number of atoms. So 1 mole of hydrogen atom contains Avogadro number of atoms, that is weighing 1 gram. So 1 mole of hydrogen is equal to 1 gram, containing Avogadro number of atoms. Similarly, 1 mole of carbon atom contains Avogadro number of atoms, and it weighs 12 grams. And 1 mole of water contains Avogadro number of molecules, that is weighing 18 grams. So 1 mole of water is equivalent to 18 grams, containing Avogadro number of molecules. Now here we don't consider in the terms of atoms, we consider in terms of molecules, because water exists in the molecular form with oxygen atom covalently bonded to 2 hydrogen atoms. So 1 mole represents the Avogadro number of particles, which could be either atoms, molecules, electrons or ions, present in 1 mole of a chemical substance. So 1 dozen represents 12 items or 12 numbers. 1 mole represents Avogadro number of particles. particles could be atoms, molecules, ions, or even electrons. Now, when we consider 1 mole of carbon, it contains Avogadro number of atoms, but the mass of carbon is 12 grams, containing Avogadro number of atoms. It is equivalent to 1 mole. 1 mole of gold contains Avogadro number of atoms, but the mass of gold is 196.9665 grams, containing Avogadro number of atoms. That is equivalent to 1 mole. 1 mole of silver contains Avogadro number of atoms, but the mass of silver is 107.8682 grams, containing Avogadro number of atoms, which is equivalent to 1 mole. 1 mole of copper contains Avogadro number of atoms, but the mass of copper is 63.5460 grams, containing Avogadro number of atoms, which is equivalent to 1 mole. So what is that we have learned from these 4 elements and their respective mass values? The Avogadro number of atoms in all these 4 elements are one and the same. That is 6.022 into 10 to the power of 23 number of atoms. But when you consider in terms of mass or the weight, 1 mole of carbon is not equivalent to the mass of 1 mole of gold, which is not equivalent to mass of 1 mole of silver, which is not equivalent to mass of 1 mole of copper. Now, these 4 elements are equivalent in terms of Avogadro number of atoms, but they are not equivalent in terms of mass. Each element has its own mass. Carbon has 12 grams, mass of 12 grams. Gold has approximately mass of 197 grams. Silver, mass of approximately 108 grams. Copper, approximate weight of around 64 grams. Why is that there is variation in the mass of these 4 elements? The answer lies in the nucleus of these respective elements, because each element has a different number of protons in the nucleus, and that is where the variation in the mass of the elements comes from. Now, considering the mole concept in terms of molecules, water and oxygen. Now, 1 mole of water is a mass of 18 grams, containing Avogadro number of molecules, while 1 mole of oxygen with mass of 16 grams contains Avogadro number of molecules. So when you compare and contrast the mole concept of, with respect to water and oxygen, we find that water and oxygen, they are equivalent in terms of Avogadro number of molecules, but not in terms of mass. So 1 mole of a substance contains same number of molecules, that is Avogadro number of molecules, but different mass. So 18 grams in case of water and 16 grams in case of oxygen molecule. So what is the key takeaway from the discussion so far? So 1 mole of an element contains same number of atoms, that is same number of Avogadro number of atoms, but different mass. And this variation in mass is due to variation in the number of protons in the respective atom or the element of interest. Like in case of proton, it has mass number of 1. In case of carbon, it has mass number of 12. Now let's consider the modern periodic table of elements. Now in the modern periodic table of elements, the elements are arranged or organized in increasing order of their atomic numbers. As you move from left to right in the periodic table and top to bottom in the periodic table. you see that the elements are arranged in increasing order of their atomic numbers. And each element in the periodic table has its own unique identity and position. So total of 118 elements in the periodic table, of which 94 are naturally occurring, while 24 are synthetic origin. So the modern periodic law arranges elements by increasing atomic number from hydrogen to oganosine. So hydrogen has an atomic number of 1, while oganosine, the last element in the periodic table, has an atomic number of 118. So each element in the periodic table has its own unique identity and position. So elements are organized in the periodic table based on their atomic number, which is the number of protons in an atom of that particular element. So let's focus our attention on 4 basic elements: hydrogen, carbon, nitrogen and oxygen, and see how they vary. Now hydrogen is the first element in the periodic table. Why hydrogen is the first element in the periodic table? Because its atomic number is 1. Its nucleus has only 1 proton. And why carbon is the 6th element in the periodic table? Because nucleus of carbon atom contain 6 protons. Why nitrogen is the 7th element in the periodic table? Because nucleus of nitrogen contains 7 protons. And why oxygen is the 8th element in the periodic table? Because the nucleus of oxygen atom contains total of 8 protons. And coming back to the elements gold, silver and copper, they too have different number of protons in their nucleus. So atomic number of gold is 79, silver is 47 and copper is 29. So now we know that why these 3 elements, though they have the same Avogadro number of atoms, they vary in the mass. So variation in the mass of these 3 elements is because of variation in the total number of protons present in their respective nucleus. Now to summarize the discussion so far about the mole concept and the significance of Avogadro's number. So element is a pure substance made up of only one type of atom. For example, hydrogen is an element made up of only hydrogen atom. Carbon is an element made up of only carbon atoms. So 1 mole of hydrogen is 1 gram and 1 mole of carbon is 12 grams. An atom is the smallest unit of an element and is composed of protons, neutrons and electrons. And during the atomic weight calculation, we kind of ignore the mass of electron as it is of negligible mass. And when we consider the molecular weight, now what is the molecular weight? Molecular weight refers to the sum of the atomic weights of all the atoms in a molecule. So in case of methane molecule, molecular weight is 16 grams because the atomic weight of carbon is 12, atomic weight of hydrogen is 1. So when we sum up the atomic weights of 1 carbon and 4 hydrogen atoms in methane molecule, we end up with 16 grams. Thank you so much for watching my video. I hope you enjoyed it and I'll meet you in my next interesting tutoring session.